Okay, Dave, just a check. Can you speak?
Hello? Yes, I'm...
I don't hear you. You're on mute, most probably.
No, I'm not on mute.
Not better?
No.
He's very quiet. He's very quiet.
You can hear it? Okay, I don't hear it. It looks like the room is hearing you, Dave.
Okay.
Very low volume, though.
It's very, very quiet.
Really low volume.
So check your volume setting.
Is that any better?
I think so. Try again.
Hello? Testing? Testing?
Okay, that's perfect now, I guess. Thank
Okay.
you. I will move you out of the queue and put it back when you need to speak, okay?
Okay, thank you.
Thank you. And I think it's 11:50, so it's time to start the meeting in OPSEC. My name is Eric Vink, and you see here Ron Bonica, and our DAD is passing the blue sheet. So excuse me, you know the story by now. And by the way, thank you for being here on the Friday last session. Thank you. There's another one here, right? If you get to. Perfect. So agenda for today, it is for this introduction, the usual one. As you notice, we do not have a JavaScribe and we don't have a minute taker. Any volunteer for the JavaScribe? No volunteer? We cannot start the meeting without a JavaScribe. Thank you. You know what you need to do, right? Simply type the name of the gentleman speaking and the presenter. That's basically it. And if you have questions on the Jabber, you stand on the mic and ask. Minute taker, anyone? Looking at the front row. Chris, you take it? Thank you very much. So, note well, I guess on Friday, the good thing is that you don't need to read it. It's the same as the old one on the other days. Blue sheet, they are circulated, so please fill them. Agenda, this is for bashing it. We will make a status on the working group document, and hopefully Ron will be there because we got some discussion about the lack of active document into this working group. So how can we get more working group document? And as you are doing quite often now, we are presenting documents from other working group because they intersect both the security and the operation area. So a mistrivia regarding the status of the working group since London. No RFCs has been published. We have 2 active working group documents. One which is the Unicast RPF check improvement, BAS 3. It published now its draft as a working group document. Is in the IETF, but it's not here today. Did not want to present any update. Draft OPSEC IPv6. As you may know, I am one of the co-authors, of the 4 authors. No updates since London. And this document is version 13. It's a real snail in the sense of advancing forward. I think the author will really need to do something about this. The Fernandagond document about extension header filtering has been through a working group last call. There was some comment, I think from Darren Dukes, and it's been addressed by Fernando. So he's published the new draft, and it's up to me and Ron basically to push it forward. So Ron, you are just on time because you wanted to get some more work done. So don't speak and eat at the same time, please, specifically for the one on the front row. I will use the chair to see.
Yes. I've noted that the working group is a little bit sleepy. It hasn't had much, as the AD yawns, it hasn't had much new work lately. And, well, I look around the room and I see it's almost empty. That's a good sign that it's sleepy. So I'd like to propose some new work. First is, a long time ago, we did RFC 6192, protecting the router control plane. Since that has happened, most vendors have gotten a little bit more clever about their ACLs for IPv6. That can probably be updated to reflect what our new capabilities. So I've asked for folks to work on it. The original author, Dave Dugal, and Stefan Fawant both stepped up, so we should see updates to that. Another thing, the IPv6 security document, there are lots of pieces of that where we kind of touch on an issue. We don't really talk about what the threat is or what the mitigation is in any detail. It might be interesting for somebody to walk through that document and see if there are any spin-offs. And finally, there was some work done by Fernando and Jen a few years ago where they looked to see how many paths in the internet would allow IPv6 extension headers. It might be interesting to revisit that work, maybe update the experimental procedure, see if we can do something a little bit more inclusive. Also replicate it to see if the findings are the same this year as they were a few years ago. Maybe even identify the ASs where extension headers are getting dropped and contact those people, figure out why. If it's for a security reason, figure out why so people will stop dropping packets with extension headers for reasons we don't understand. So anyhow, all ideas for new work that we should start. I've pinged people, and for the most part, people have been interested in doing the work. So expect new stuff.
And obviously, if you have suggestions for work, feel free to come and propose them. Okay.
Gary Fairhurst, we have a tool that we use for probing the internet for all sorts of things. If people here understand the extension header thing well and exactly what they want to reproduce, we could put it in our tool and we could run it on 1 million targets and just do it. But somebody's going to have to work with us to tell us exactly what was done previously and what it is we're looking for before we invest time kind of putting tooling in.
Is there a place where we can look to see what the tool looks like?
Yeah, it's called Path Spider.
Mm-hmm.
And if you Google Path Spider, you'll find a website and the open source for it.
I'll do that.
But we can do plugins, and we have the people who can write the plugins currently around. So,
excellent. Thank you so much. I'll take a look at that.
Okay. So do I, by the way. So let's go back to our normal program. And Benno, it's up to you.
Thanks. Thank you. So, well, quite happy to present this draft also in the OPSEC working group. So earlier this week, Sarah, so these are my co-presenters, co-authors, Sarah Dickinson, Roland van Rijswijk, and Alison Menken. We presented this draft earlier in the Deprive working group. So it has some overlap with the previous presentation, but I want to give a little bit more context how we came to write this draft.
The clicker is there.
And of course, what we expect feedback from this working group. So a brief history of DNS privacy. DNS was never to be meant private. It was always in the clear. But with the Snowden revelations, there was this action in the IETF, broad wide, and one of the actions was the IETF Deep Dive Working Group. So we looked into it. There were a number of RFCs. You see here the timeline, 2015, 2016, 17. It is about DNS privacy coordination, considerations, and more the implementations. So it's kind of what are the threats and how can we deal with it, and the different implementations to protect the privacy of the DNS and its users. Two important outcomes are DNS over TLS, DOT. I will use that quite often in the remainder of the slides. DNS over DTLS, there's an RFC, but until now, no implementation. And in 2017, we mentioned DNS over HTTPS. So there's also encryption here and privacy. So we mentioned that later also in the draft. And interesting enough, there are also public resolvers offering DNS privacy, which is Quad 9, one of the first. There is Cloudflare, I call it also Quad 1, with DNS over TLS and DO. And this is recently also Google has an experimental DO interface, maybe even more than experimental, but I have to look at Warren. Okay, that's what it is. Okay, thanks. Good. So Sarah, Roland, Alison, and I, we came up with a document, because if operators want to run their own DNS privacy service, what are the minimal requirements? What's the moderate requirements, and how do we can have kind of an optimal configuration of this DNS privacy? So we want to give really practical directions to the operators. And so these are the operational, policy, and security considerations. But with that, and that's also important, what do you do with the data on the server? So these are the DNS privacy policy and practices statements. So what is published, what operators will do with the information, how long will it stay on the server, etc. The retention policies. So it has documents two goals, and I think I'll come back to that later at the end of the presentation. Current deployment of DNS privacy services. Sarah, does it work? Yeah. Well, not anymore. Doesn't matter. So the DOT service, Sarah maintains a website, dnsprivacy.org, and that has 20 test servers. These are people like you in the room, organizations. They set up their DNS over TLS recursor and open that to the public to test DNS over TLS traffic. There are the large-scale operators, the Quad 9 and the Quad 1. For DO, there's the Google and Cloudflare recently to test with. For Cloudflare, please correct me here, so the Firefox nightly currently uses the Cloudflare DO.
Actually, I spoke to one of the Firefox people yesterday.
Yeah.
And he says, I'd also read it as, they use it for that.
Yeah.
Apparently, they've only opted in, I think, 25,000 people out of their whole big selection.
Oh, right.
So it's just a tiny bit at the moment.
Yeah.
Their feedback is so far, it seems to be working really well for them. But yeah, I also had been confused about that.
Yeah.
And they do also pop up an interstitial saying, hey, just so you know, we're doing this for you. We hope you like it. You can opt out.
Yeah.
Which from the stuff I'd originally read, I hadn't known. So I figured I'd mention it.
Okay, it's good to hear that they have this, a group of selected people testing it. Excellent. So this is the current state. So what about the document? We submitted this draft, the BCP, best current practices, to the Deep Dive Working Group at the IETF101. So we get some initial feedback, and it was very prescriptive. So people, didn't want to put it more in a context. So why should I opt in, opt out certain features? So we contextualized a little bit more. we presented this document also at the RIDE meeting, best current operational practices for operational input from the room. And last week, of this week, we presented a new document, well, the same document, but more contextualized and put things into perspective. And also, and I repeat again, more what's the minimal requirements, what's the moderate, and what's the optimal or the perfect settings for deprive DNS privacy. So, a little bit overview of the document. I hope to get some feedback, or we hope to get some feedback from the working group, and open discussion for improvement, etc. I think let's go on. We touch everything. So we have some definitions here. It's also in the document. A privacy-enabling DNS server. Well, it supports, it implements DNS over TLS, and also we need to add more text about DNS over HTTP. And how do we authenticate DOT service or DO service with search, SPKI. So there's some definitions here. But the DNS privacy service is everything above, a privacy enabling DNS with some documentation, and that's a statement about policy and practice. Or a formal DPPPS. I come to that back later. Right, operational guidance. So the goals is, we try to set out in the document, the goals to reduce user tracking and information leaking via the upstreams. So user tracking from the stub or the user to the resolver, and the upstream from the resolver to the authoritative. We define here three here's server capability. So it's on the wire. That's from the stub end user to the resolver. At the resolver, how do we deal with information and data queries actually send upstreams. On the wire, this is clear. We have the protocols, we have the authentication, certificate management, and some specific options to make it even more difficult to track users. So padding of the headers, something like that, cookies and the performance considerations. We have data at the server. So of course there's some real-time monitoring to run your server. That's we all understand. But what about logging, tracking of users at the server? Who can get data access and cache snooping? These are still some empty headers in the document. So we need text here. But this is the outline mainly. But also indeed, we have to talk about pseudo-anonymization or anonymization of the data on the. So if you want to do some analysis of the data on the server for operational, how can we protect the private or the privacy sensitive information on the server? So this is now more or less a discussion, not very definite, but input is very welcome here. Let's see, let's consider, this is the upstream, and that's important. So it's not only about encryption here, but upstream is also leaking information to the authorities. And there's a DNS option, QName minimization, so you don't ask for the full qualified name to an authoritative name server, but only the label you want to have to find a delegation for. So to the root you only ask for .com. For .com you only ask for. Let's stick with IETF. What do you want here? Example. Thank you, Digaji. Always forget about that one. So at the .com we ask about example, and example you finally ask example.com. So you don't expose more information than strict necessary. Traffic obfuscation and data sharing. So sometimes, there's an overlap with data at rest. Right. And how do we time-wise?
We have 10 minutes.
10 minutes. Okay, that's fine. I'm almost ready though. So the DNS privacy and policy practice statement, DPPS. That's a kind of, that can be a formal or a less formal description what you do with the data at your server. And so actually Sarah is now looking at the different policies and statements of, for example, Cloudflare, Google, and I think we mentioned here someone else. Google, Cloudflare, Quad9, and OpenDNS. Yeah. And we want to compare them. So to which extent do they overlap, differ, and can we kind of formalize or automate this process so that it's easier for the user to see what is covered and what is not covered. Right, this is more the same. I just mentioned this. Let's see. I think I mentioned everything here I want to talk about. So what I really like to ask the room here is indeed get some, well, this is, of course, this presentation is getting your interest in the document. Read the document. Of course, I'm here also to answer more specific questions I might not be telling right now in this presentation. But we also accept feedback, review, and comments on to improve the document. So let's see. One thing I want to mention the discussion in the DPI working group. It was positively received by the working group, but there was a discussion. What about a BCOP or BCP, which has to be kind of a strict list of things you has to comply to, versus the data policy, which is a little bit less strict. So if you want to be PCP compliant, maybe you should split the document in some prescriptive things you should implement as an operator, and a more data retention compliance document. Others say, well, it should stick together. It should stay in one document. So this is a kind of ongoing is a current discussion, but altogether there's interest in the document for the working group. So there's a working group call for adoption on the mailing list, and from there we want to proceed. Another thing, and that's it's a BCP. It will be published as an IETF document, but you also might want to have kind of a living document. We don't have a clear idea how to proceed here or how to implement this, and that's quite more often in the operational world. You want to adopt your document to the latest, best current practices. Good. That concludes my presentation. Any questions, comments, feedback?
Hi, Maarten Aartsen and CSCNL. So one of the things I really liked was the big table you included, comparing some of the operators.
Yeah.
What I was wondering about is, so I would imagine that this is one of the parts of the document which has the most chance of changing.
Yeah.
How would you deal with that? Will it be an external reference, or will it be included, or?
Yeah. So currently, Sarah is maintaining the dinisprivacy.org website, and again, indeed, that is also from the working groups and the community. I think that's the best place to live such a table where the different operators and how to comply and what they do offer and don't offer. Indeed.
Yeah. So then you work around the problem of having to update the document itself. Yeah. Makes sense.
Yeah.
Okay, thank you, Bruno.
Thank you.
So next presenter is remote. So Dave, if you can step forward and meet the echo, and tell me when I need to switch slides. Is he coming? So Dave, can you come forward? Okay, perfect.
Hello.
And we can hear you.
Okay, great. So, there's a rather distracting echo, which I'll try to ignore, perhaps by muting my own microphone.
No, you are muted. Indeed, no echo. But
Oh,
it's not-
no. Okay. Is that any better?
Yes.
Okay. Okay, great. So what I'd like to talk about is some context, and then about the draft that I produced. So carrier grade NAT is what it's about in general, and it produces an information gap when it comes to criminal investigations, basically, and a proposal for how to deal with this, which is logging of source ports. So if we could move on to the second slide, please. Okay, so on the right-hand side, we have an ISP, and the ISP is, in virtually every jurisdiction, is required to retain logs that allow for the identification of their subscribers should that information be needed in a criminal investigation. And RFC 6888 provides common requirements for carrier grade NATs that outline what those logs, it's recommended that those logs consist of. And what it generally consists of is time, the external IP address and the external port, the protocol, which is not shown here, and then which subscriber was using that information at a particular point in time. So you can see those logs there on the right-hand side. However, here's the problem. Most victims, say, for example, a website that has been hacked, or most service provider platforms, only keep logs of IP address and time. And what that means is that when it comes to the criminal investigation, you find out the IP address and the time, but you can't figure out which of the subscribers it was because you haven't got the port number that they were using. Sorry, everything is looking a little crazy. Can everybody hear me okay?
Yeah, yeah.
Okay, fine, thanks. So that's the problem. There's this information gap between the information that is retained in the logs that are being recorded by, say, a victim or a service provider, and the logs that the ISPs have. Everybody thinks they have enough information, but there's this gap. So how to deal with this gap? There's basically 4 options. So if we move on to the next slide, please. Option number 1, which is the least preferred of the options, and this is discussed in RFC 6888 as well, is that the ISP must record not only the IP address and port on their side, but also the destination. In other words, what you have to do as an ISP is record every connection that all of your subscribers make outgoing, which is a problem for the ISP in terms of the volume of records that you're talking about, but also it's a huge privacy problem as well, because you're retaining a massive amount of information about your subscribers, and the implications of a breach are very substantial at that point. But it is a solution to the problem. So if we move on to the next problem, or the next slide, please. Solution number 2 is migrate to IPv6, which effectively eliminates the need for carrier grade NAT, because everybody's got an internet IP address, no NAT is required. The ISP gives you an IP address, you use that IP address, or a prefix indeed, it may be a prefix, but nevertheless, the carrier grade NAT problem goes away. Third slide, or next slide, please, which is solution number 3. That's don't use carrier grade NAT, or severely limit the effectiveness of carrier grade NAT through either regulation or voluntary code of practice by ISPs. So, for example, an ISP could say, I will only have a maximum of 16 subscribers using a given IP address at a given point in time. That way, if an IP address is associated with criminal activity, you can tell that it's one of those 16 IP addresses, or at least one of those 16 subscribers. I really don't like this idea, because what about the 15 innocent people? And it's not a great one. But anyway, it's what some people have chosen to do. And finally, if we move on to the next slide, please. If the victim had logged source port as well as IP address, then it will be possible to uniquely identify the subscriber without changing what the ISP is currently recording. So this has been proposed by an RFC previously. RFC 6302 recommends that internet-facing servers record not only IP address but also source port. And so when I approached this problem, what I was thinking was, well, this recommendation has been out there for many years now. What year was 2008 or something like that 6302 was published. And what I was asking was, well, so everybody kind of knows they should be doing this. Why isn't it being done? And so what I did is I did some analysis. I wrote a draft and I slightly changed the recommendations of 6302 because they were a little bit out of date, but also some analysis to make some more recommendations for making this a routine, making logging of source port routine at internet-facing servers. So some of the challenges that I identified are shown on the next slide. The first is awareness. Most people don't know that there's a problem until they become a victim, and then they find they haven't got the information to identify the person who hacked them. The second is that some in server software doesn't support the logging of source port, not without introducing a very verbose level of logging, which would be unacceptable in a production server. The volume of storage required can be a problem, but isn't really. Another one of the main problems is that logs don't live in isolation, and usually logs are processed by scripts. And if you change the format of the logs, you break your downstream tooling. So that is another one of the significant challenges to the logging of source port. And finally, the accuracy of the times in the logs can be a problem as well. You need the logs to have accuracy of at least a second. So these were the main challenges that I identified. Moving on to the next slide, please. I then did some analysis of a selection of different types of server software, looking at whether or not it was possible to log source port. And fortunately enough, in most cases, it is possible to log source port in most common server software. And then I looked at whether or not it was feasible. And by feasible, I meant, is it possible to log it in a way that wouldn't severely impact the production performance of the server? In other words, I don't consider it to be feasible to log source port if you have to enable a really verbose level of logging. So there are some server software packages that only enable, wherein it's only possible to log source port if you are doing debug logging. The next category is default. Are there any server software packages available that by default log source port? And I was only able to log one, or identify one, which was OpenSSH. No other software package that I could find either by default logged it or had in its configuration a configuration section that would have allowed for the logging of source port. Then there's two other questions where there's virtually no information available, which is, supposing you have a large volume of logs generated, querying by IP address and source port, is that possible? How do you manage the logs, and is the information in those logs accessible? I have no information about that, and I couldn't find any sources of information about that. So what I did, next slide, please. What I did was I published an internet draft, which is now on version 4. And I presented this at IETF 101 to the INT area group. And I also participated in an extensive discussion on the INT area group. Speaking candidly, it wasn't tremendously favorably received by the INT area group. I think it would be fair to say, because there seems to be quite a bit of resistance to any form of logging whatsoever, any form of additional logging whatsoever, or making any recommendations for any form of additional logging. But nevertheless, I found it to be a useful discussion, and it did help to advance my thinking on some of the problems, and I would appreciate if people have any feedback. I'd definitely be very interested in hearing what it is. I also thought I'd just do a little plug for the landing page for my work on this is the top of the other two links there, the one that ends in carrier grade NAT, where I have links to the presentations that I've provided on this, the documents that I've published on this, and I keep that maintained. And then the bottom link is a link to my blog. You can get the RSS feed on that page if you want. And that's really all I wanted to say. I wanted to present you with the challenge and then show you what the possible solutions were and why source port logging is, of the available options, somewhat the kind of least worst of the available options for dealing with this problem. The 4 solutions that I outlined, the connection logging, IPv6, don't use carrier grade NAT, and source port logging, all of them have been tried and all of them are in use somewhere or other in the world. And but the source port logging, I think, is the one that solves the problem with the least privacy implications for most people. And that's all I have to say. So questions or comments would be appreciated. Thank you.
Any questions for Dave? One question is coming.
Stephen Farrell. Hi, Dave.
Oh, hi, Steve. How are you?
I'm good. I hate to beat up on a fellow Irish person, but yeah, we had a long discussion, as you say. I think you correctly summarised it as not being favourable, and I don't believe the draft has changed since that discussion. Is that correct?
I don't think so. No, I can't remember whether.
And so I think there was a number of valid points raised against the current text of this draft, and in that discussion, I'd encourage people to kind of review that on the interior list. I don't think we have time, or it's probably not appropriate to try and revisit them all here right now. But just another pointer to that discussion. For me, the biggest one was, if we're going to do something about this, I think we should do a proper analysis of the privacy impacts and others of doing this, and not just focus it, as Dave's draft does, on one particular problem.
Okay.
Okay, and sorry, just one small comment in response. I did try to initiate a conversation on the interior group about law enforcement requirements, and I got no replies to that. So try and initiate a broader discussion, but yeah, that is what it is. So
yeah, I mean, I acknowledge that you did. Yeah. But again, I think it's not just law enforcement requirements. There's many other people with requirements.
Yeah, I agree.
This is Daniel Kahn-Gilmore from the ACLU. So I appreciate that you're writing down the concerns and that you've pointed out that we could be doing much worse in terms of privacy by offering solution 1 there. I agree with Stephen that we really should be thinking, if we're thinking about trying to make logging recommendations, we need to be thinking much more clearly today about what the privacy concerns are for logging recommendations, including questions about how you can reliably ensure your logs are destroyed as soon as possible. And so I would be much more interested in seeing this as part of a bigger question about how can we help people who end up having to keep some logs, keep as minimal logs as possible. I had an additional point for you also, which is that I looked at your blog page and I'm getting PHP errors with the PHP messages published.
So
you might want to check to see what source port that came from. So,
okay.
Thank you.
Thank you.
Okay. No more questions are saying. Thank you, Dave.
Okay, thank you.
Wrong one. So, Gori, up to you to present us an update compared to IETF 100. And the clicker is here.
Yeah. Hi, I'm Gori Fairhurst. It's good to be here. I'm going to talk about this draft. This draft's been around for a while. It's currently at Rev 9, which means it's more readable than it was. It's actually, I'm going to try and persuade you it's very readable. It's about the impact of transport header confidentiality on network operation and evolution of the internet. The aim is to talk about just the impact that we know on the way networks are currently operated and the evolution as a whole and where it may change this. We are not trying to make recommendations for what happens next in the IETF protocol series. There are other documents that might do this. We're looking just at the transport perspectives, but it's about an operations and security thing, so it's probably good to talk about it here. My co-author is Colin Perkins from the University of Glasgow. How do I get half a slide? Someone help me. Great. Right, fine. Aims and goals: identify in-network uses of transport layer header information. If anybody has additional uses that are currently being used or have recently been used of transport header information to help operations, to analyze performance, to support users, we'd love to know. Review the implications of transport protocols that use integrity protection and encryption to protect the transport protocol header. What are the things we know that we might gain when things are encrypted? What are the things we may lose when we encrypt transport information? And discuss their impact on transport protocol design. This is a transport activity, so it's primarily aimed at the transport protocol design, but network operation is also part of this inherently. And finally, we have a small bit which speculates about the impact on transport and application evolution. Status is there's been 3 revisions since IETF 101. These revisions have been to try and reposition this document better. It's important that this particular document takes a view, which is the consensus of the IETF community. We're putting this to TSVWG as a work item for the group to work on. So we need feedback from different people. At the moment, we have taken a lot of feedback from Al Morton and Kathleen Moriarty, Spencer, Joe Touch, Chris Seal, etc., who have been helping us. More people, very, very welcome. I know people from this group have actually helped in the previous round of revisions, so I also explicitly say thanks. There's some related work, and my primary point of putting these on the slides is to indicate that this is the only document in this space, but each of these documents is meant to be complementary. The 2 documents that are mentioned here are about other aspects of this problem space, and we don't intend this to be overlapping or conflicting, so we will work with the document authors to make all 3 documents progress if these documents also progress. So what's different in the work over the last time I spoke to you? The main thing is we've tried to adopt a neutral point of view. We've realized that there's value in publishing things in the IETF which look at difficult topics from different perspectives, but present them neutrally so that other people can read them and we don't end up with a great big bun fight and lots of exciting emails when people just take different positions. So we've tried really hard to make this document take a neutral point of view, to expand a discussion of the ossification problem and why people want to use encryption, and also to include a little bit more operator feedback on how people have been using packet headers for running networks. Just again, we'd love to get more feedback on this. I have lots of anecdotal conversations with people, but the more I hear, the better it is to understand how exactly people are currently using TCP headers, RTP headers, etc. in the network, and what the difference will be if these are encrypted. We added some notes also on accountability and network neutrality, because I've been helping some people with network neutrality stuff and trying to say what is a network neutrality issue and what isn't, so we added that a little bit also to this. The security considerations have been added, so that's really good to get feedback on. Please look at the security considerations, because we started to kind of unpack what we think are the takeaways from this document in that section. And we also added a conclusions section, which I think would benefit from much more review. So what's the status? The status is we talked about this yesterday in TSVWG, and there was support for this, for adopting this as a working group item. We're going to take that to the list in TSVWG and confirm this, and then hopefully adopt the document shortly after this IETF if there is feedback on the list to support it. If you want to comment on the TSVWG list on adoption, please do. If you want to comment on any aspect of this, please do. We're looking for review now from the operator community, from those people with security considerations, those people who think that this document is not the right thing to do, those people who think the wording is not quite right. Yeah, please shoot at us. Please help us get this right, because we want to create a document that's generally useful to the community. I think that's it. It was short, but the point is the document's actually now readable, so you can actually go and read the document. Oh, I should say thank you to Stephen. Thank you, Stephen, for comments. A lot of comments. Please tell me something.
So I appreciate the attempt at neutral point of view, and I think it's. I haven't read it since Christmas. I think was the one I reviewed, so it's a long time ago. But the little quick scan of the diff I had, it does seem to be improved in many ways. That's good, and I will definitely review it. I would support adoption of a nice neutral point of view document like this, like I did with draft NMM Encrypt. Sorry again, Warren. And I have a question though. So you note a bunch of the benefits of looking at headers today and in the past, and some of the benefits of encrypting confidentiality of those headers. Do you have any information about the abuses of that header information in the past? Has it only ever been used for good?
No, it has not only ever been used for good.
And would it?
And do I have information? Yes. But that's not. Neither of these questions are actually helpful, because the thing you're leading to is, can I say something about it? Now,
well, adopting a neutral point of view would seem to me to call for noting the some of the things that were problematic that are being improved upon by the transport header encryption.
Okay, so one of the things we could definitely talk about, which we kind of started to unpack just this IETF, is we could make a list of points where not encrypting things has really acted as a problem to the transport layer. So this isn't a security thing, but it's a revealing it is a strong, has really impacted bad things going on in the transport. I mean, I'm talking about MPTCP, I'm talking about MSS clamping, I'm talking about horrible stuff that goes on with TCP middle boxes. These aren't security implications, but they are reasons that drive the need for security from that perspective. Is it wise and good to open some of the more security questions?
Well, from the point of view of a neutral approach, it seems if you're noting some of the benefits of the past practices and some of the benefits of the new practices and some of the problems of the new practices, some of the problems of the past practices seem to be a logical thing to include.
So I can give you a handful of ones why transport protocol design requires this. Could you perhaps help me find a handful of ones from a security perspective?
I'd be delighted, but I'm not suggesting that we try to identify issues now, but just I think taking the neutral approach seems to require that fourth leg of the stool.
I'm okay with this. Let's see what comes out, but let's keep the list short and useful examples so that we can actually figure whether people like this and build from there.
Sure. Well, I would argue that it should be as complete as the other three legs of the stool.
If you think so, please help me. I appreciated your help last time, so please do again.
I don't think there is any more questions, so thank you, Gary.
Oh, well, okay.
Yeah, we've been introduced to your paper, right?
So my name is Mia Kulewind. I'm also mostly working in the transport area. And Gori gave me just a very nice introduction to the work I'm talking about here. That is a draft that I'm co-authoring with Brian Trammell. And it came out of our work we do in transport and transport evolution, also a little bit in the quick working group, but it's also most actually of the input is coming from the IEB stack evolution program. So that's an IEB program looking at how to evolve the stack on various layers actually. What the draft does, it defines what a wire image is, because that term comes up more often and there's some confusion about it, and so clear definition makes sense. But before I give you the definition, I start a little bit back there. Yeah. With the problem, and I mean, it's the same problem that Gori is addressing, and I just tried to spell it out more clearly so we all talk about the same thing. Actually, I have a screen over here. That's great. I take the mic. Yeah. So the stack that like was originally designed, which is like kind of titled here as the 90s style stack, is what we all also know today and learned at university or school or somewhere. And it didn't really include security that much, but it had a clear separation of layers. And the transport layer was really meant to be end-to-end operation. So all the information you need at both of the endpoints to make some communication going. Given the fact that this information is visible, like as all the other layers, to everybody who is like involved in the communication, so all the middle points, all the endpoints, every passive observer, there has been an evolution of actually doing a lot of additional things with this information. An easy example is you look at the ports and you do some filtering of the ports. More complicated is you use some of the transport header information to do like round trip time measurements. You can do loss detection. All this information is used in various middle boxes in various different ways, for good and for bad. So that wouldn't be a problem on its own. A problem really appears a little bit more if you actually start also to change this information. And at that point, you make assumptions about what these informations are used for at the endpoint, and you try, of course, to change them in a way to not interfere with the endpoint operation, but that also means you cannot evolve the endpoint operation anymore. If the assumptions how these information have to be used are not holding anymore, if you change something, everything breaks. And then there's actually, of course, another aspect where people actually go deeper in the layers and use all the information available there. And at some point, you even go to the payload where you might have like privacy sensitive or like just private information that should not be accessible to everybody. So clearly the solution is security here. You want to encrypt your data. You want to make sure only those data is accessible to those people who need them. So what we did is we built transport layer security, which is actually on top of the transport layer, so in the application layer, right? Which gave us the possibility to encrypt everything that is, as I said, on top of transport. But still, like this end-to-end operation, which is also meant for the endpoint, is still available, it's still open, it's still readable, you can still modify it. That's good and bad, but definitely has some evolution and ossification problems. Deep package inspection is still kind of possible, but definitely more complicated. So you have to like get the keys somewhere, or you have to break the encryption and like intercept another point in the middle. So what we see right now is something more like this, like especially with Quick, where you have end-to-end information that is part of the encryption envelope, and you have end-to-end information that is outside the encryption envelope and still readable. That doesn't, so like even so both is like part of the transport header because you needed to operate your transport layer. Part of that is visible and really only accessible from the endpoint, and the other one is outside. And the reason why this information is outside is not like always explicitly because it's used by the pass. Sometimes it's just information you need to set up actually your encryption context, so you cannot hide it from the pass. But it's also this awareness that all the information that are exposed to the pass now are available to the pass and can be used or misused by the pass. And like developing a protocol with those notions in mind gives you different aspects and different decisions to make. So you have still the end-to-end operation, which uses mainly the inner information, and then they still have some modifications or inspection on the outside. Actually, modifications also not that much anymore, because you can also use this encryption context to at least integrity check your information and make sure that they don't get modified, at least in the transport layer. So the wire image is basically this part, everything that is visible to the network, right? And when I say everything, it's actually not only the outer transport header bits. So the outer transport header bits is some information that is clear what they mean and you can interpret. But after all, the wire image is like everything that is visible to the part, which also means having this blue box here and knowing the size of the blue box is also some information that's visible to the path. Knowing the length and entropy of all the bits of the packet is part of the wire image, and also the timing of the package, because that can reveal information about what the application is doing and the application that is on top of that. And that's what we mean by wire image. That's why there's a difference between outer header bits and a wire image. It's like painting the whole picture of what your transport does, right? What your connection, your traffic does. So why is it important? So first of all, it means like there's this very concrete boundary, and like not as much information is available as before. And also we can now much better understand how to interact with anybody on the network, because we operate under the assumption that these information are available and may be used, or maybe should be used even. So for the design of the transport protocol, where I'm coming from, it is also important to notice that whenever you provide some information in the outer header bits or somewhere in the wire image, that you should think about how this information will be used, can be used, should be misused, and not only think about the information itself, but think about like the whole wire image for this specific protocol, for this specific application, and make your analysis there. Yeah, the second point here, it's also giving we have this clear boundary, we have a chance to decide if it's inside or outside, and we have some integrity protection, we can actually make a clearer decision about which information to expose and when. And so providing the information if needed in a case where like you want to do troubleshooting, for example. From the operations point of view, of course, what I said already, it's like it's not the same as you have before. It's less bits, it's less information, and you have to adapt to it. But that's probably not the new message here. I guess this message came already to this room. But the positive part of this is also that if you have a signal in your wire image, then it's more designed to be usable for the network as well. And like one simple example is, for example, the TCP timestamp option. So first of all, the TCP timestamp option is an option, so it's not always there. If you want to use it for measurement purposes, then you have to be lucky it's there, and you have to detect if it's there. So that's already some overhead. And then if you actually want to use the timestamp information in the timestamp option to get round-trip time information of a flow, you have to understand both of the clocks, basically figure out what the initial values were, and then calculate complicated difference between like the value in one packet and the other packet. While like as a different example, the spin bit that we're designing in Quick, it's explicitly designed to provide round-trip time information, and therefore can be monitored much easier. Yeah, so after all, the message is that there is this document, and maybe worth a read. It's a short document. There is a second document, which Gori already also mentioned, which goes with the document. So the first one really just defines the wire image, what I told you here right now. The second one talks also a little bit about the benefits about being explicit as a pass signal, and how to implement this and how to design this in new protocols, where the current approach really is that we have to consider this in every protocol kind of separately, and for every piece of information separately. Both of these documents are IAB documents, so the first one doesn't have the IAB tag yet, but just because we didn't submit it in time. So they are under discussion in the IAB and will probably be published as IAB consensus documents. Beside that, you can still comment on this document from the community. So I think the right email list for that is the Stack Evo Discuss mailing list. So from the Stack Evo IAB program, there is a public-facing mailing list that everybody can comment on.
Hi, Mira, it's Gori Fairhurst again. Yeah, that's okay. But you just draw a grey blob and a blue blob. And when I talk to operators and they don't see what they like in the blue blob, then they add a pink blob in between, which is the end-to-end or edge-to-edge OAM signaling or GTP encapsulation with options to do timestamps, because I no longer see timestamps. So there's an extra bit to this evolution, which I don't know whether you want to consider, but it's the fact that if you don't make transport headers available, then operators who want to do timestamps and RTT measurements will simply add a tunnel header and consume bytes doing that to make that happen. Is that something that's actually interesting, or is that another orthogonal space, or what?
So I think actually in the wire image, that's maybe a little bit hidden between the line, at least maybe not the tunneling example, because there are many reasons to use tunnel and like they will not go away. But also the fact that you have to see everything, not only the bits and the information you reveal. There's like in the wire image much more information about packet timing, packet sizes, and so on. And if you don't provide an explicit way of providing information network needs to operate, then they will try to interfere this information from everything they can get, which is a risk. So that's like, actually, that's kind of the connection between the two documents here.
Yeah. Right.
And we can figure out if we can spell this out more explicitly, but it's definitely in there.
Yeah, I mean, if I wanted to operate a network and I want to measure packet loss in RTT, and I can't find a way of doing it because maybe it's IPsec encrypted or whatever, I don't know, then I can just add a edge-to-edge header on it and take some bytes and add my timestamps. There's plenty of IETF specs for doing this. So it doesn't go, you don't make it private, but
no, but I mean, actually, so the problem with that is that like the MTU is limited and it gets smaller, and that's also not something that we want. But in fact, that's also not something wrong, right? Like if you want to do measurements in your network, you can do active measurements, or you can add some information. And like I understand the need for doing measurements. The thing that we have to carefully consider is whenever we connect a mechanism to the endpoint mechanisms, that we make sure we don't reveal information we don't want to reveal. So the risk when you actually add some tunneling headers is probably smaller than that. But again, this is also a protocol where you reveal information, and you should like design it carefully in the content of the whole wire image.
It maybe depends on which network you're talking about. If you're near the edge, I probably know a lot of the stuff anyway.
Yeah.
Hi, Stephen Farrell. Just I had a question about your definition, Adam, which is about the only part of the document I read. So, sorry. So it looks to me that the definition doesn't quite capture issues like sending multiple messages in a single flight, as is commonly done in TLS, for example. And I'm not quite sure how that might impact on things, but the definition seems to assume that you can see the protocol messages in the wire image, even if they may be multiple messages could be sent in who knows what order inside the ciphertext.
So, I mean, actually, it doesn't matter where you put the packet boundary, right? Because the wire image covers like everything anyway, right? Like, it doesn't matter if you have some unencrypted bits in the front and another piece of unencrypted bits in the head. Like, everything you can see that belongs to the same communication is part of the wire image.
Right. I don't know if it matters or not, but I think your definition assumes, the definition says that you can tell you have an arbitrary precision time for each protocol message, where it's maybe for each number of ciphertext to do, but not necessarily for each protocol message.
So I mean, like this might be a way to migrate to reveal this information, right? But at least the packet boundaries you cannot take away. So like if you have multiple messages encrypted inside the same packet and you cannot see the boundaries there anymore, then you reveal less information. That's fine. Yeah, and then you don't have to consider it anymore. Like, do we talking past each other?
Mine is nearly a knit with the definition, but I have no idea of the consequences of that knit. So
it might be true that the wording is not perfect, because this thought that actually timing is relevant came in a little bit later, not in the first version. So maybe we can actually work on the wording there.
Yeah, so I think that you see the timing of the ciphertexts, but not of the protocol messages.
Yes, but that's the point. I think like maybe yes, we agree. Maybe it's not written the way it should be in the document.
Okay, everything without any chairman hat here. They don't read the draft, but one slide, and you skip quickly on it, was about the timing of the packets and the size distribution of the packets. So it's considered as part of the wide image, right?
Yes.
Okay, which is good. Do you propose anything to fight against this?
Definitely not in this document. But so the only thing I really recommend is to consider all these points when you do your design decision, right? But whatever the trade-off is a decision for like this specific protocol for that specific use case. So I don't think it's possible to make a general recommendation here.
Fair enough. Thank you.
This is DKG. So thank you for writing this stuff down. I think this is really useful as a reminder for those of us who design protocols. And we're already following some of this guidance, I think, within the IETF. So I think it's very useful to have this kind of framing written down. And yeah, I would agree with Stephen that the location of the protocol data units and the actual packet edges may be different, and that's worth highlighting. In answer to Jeff, your concern, I think, about that you could just, Corey, sorry, I apologize, was that you said that the network operator could add things to the outside of the packet. That's surely true, and we're not going to change reality by mandating otherwise in the IETF. But that's within the network that you control, and not something that the endpoint needs to decide on your behalf, right? So I think the point that Miria's draft is making stands, right? That the endpoints need to think as clearly about the information that they leak, regardless of what the network operators might tag or annotate a packet with.
Gori Fairhurst, I'm wondering what happens when we have mobile operators who appear GTP and then start exchanging their OEM across it. And they'll never do that, of course. So there is a place we can put information here, and that information currently will be contained within the edge of a network. In the future, that doesn't have to be the case if people agree to do other stuff. So just have to be a little bit careful about where things can go. If you squeeze one place, they might appear somewhere else. That's all I'm saying. Does that answer the question? Because I think it's a useful question.
I think what you're saying is if we hide this potentially sensitive information, some parties might try to add it back in with tagging. And the end result will be that there is still less sensitive information flowing around on the network, and that's a positive win.
So you can also say if you hide non-sensitive information, then the incentive to actually try to add some of the information back is like high, and then like the risk that it's added in a way that it's not how you want it to be added might be higher if you don't provide it yourself.
Okay.
Okay, so my take is it should improve the security perspectives on this. So I agree on that, but it may create more options for how you use this data and then fragment how people do it, and may end up with more information being added than you would have needed to add it in another case. So you maybe benefit security, but you maybe create more complexity in the OEM and management infrastructure as a result of this. So do you want to talk more on that? Somebody?
Just Stephen Power, just answer Maria. I mean, I think we have a fantastic history of not realizing what is sensitive information.
Yeah, sure. But also it's the question about who has the control about the information, right?
So I'll just observe that if the network operator is making decisions on the basis of this metadata that's potentially leaking, and those decisions have a way to impact the quality of the traffic.
Let me give an example, maybe. We talk a lot about linkability.
Mm-hmm.
So if you want to, like if an operator decides I want to add a timestamp for whatever reason and leaks this information to the other networks as well, and the operator, because that's your access network, knows actually all the flows that belong to you, you can get a linkability between different flows that you don't want, and that's just because the operator did implement it stupidly and leaked the information it didn't want to leak, right? So if the operator already had a way to get like information in a secure way, you wouldn't run the risk. I mean, like you could still have a stupid operator, but the risk would be lower.
So I'll just observe that the network operators could do these kinds of stupid accidental leakability tricks already, right? And they do. We have evidence of the Verizon super cookie. AT&T did a similar thing. The fact that we are not linking something is not, the fact that we are going ahead and producing linkable data publicly is not going to prevent the network operators from leaking that information as well, right?
No,
and if the metadata that's being leaked is something that the network operators operate on, I guarantee you that endpoints will start to lie about it. In which case, the network operators again have an incentive to go ahead and make their own mistakes and add their metadata back in. So the better approach is, I think, what you're outlining here, or what this is pointing towards, which is to go ahead and hide as much data as you can, so that the network operator passes the traffic. So that's what I'm seeing.
Okay, and the counterpoint to that would be that forces the operators to use things like machine learning for categorizing all the stuff that they need to find, which will produce a more variable and less useful service and consume more CPU. There's trade-offs here. This is a straight trade-off thing. Security is probably the most important thing, but if you drive only on increasing security, well, maybe there are outcomes.
So I definitely want to clarify that none of the two drafts recommend to hide as much information as possible. Both of them recommend to figure out which information is visible and design your protocols carefully and make sure that if you leak information, that you explicitly decided to do so.
Okay, thank you. 20 minutes or 15?
Ron Bonica, and welcome to the last presentation of IETF 102. Is everybody's brains fried? It is, yes. Okay. Okay. Everybody's brains are fried, and I assume that people are just about tuned out now and not really paying attention. So I'm not going to use my slides at all, and I'm not even going to stand in the pink blocks. This is going to be an unorthodox presentation. Okay, I'll stand in the pink box. But I have a question, and the question is for our glorious AD. Come to the mic. Yes, you're going to be cross-examined. You've been subpoenaed. Would you agree, Warren, that DNS is one of the most essential applications on the internet? If DNS went away, we would all be screwed, no?
This feels like a trick question, and you're leading me down somewhere where I don't want to go. But yes.
Yeah, it's really, really, really essential. Would you agree that DNS, especially when we're using DNSSEC, kind of relies heavily on IP fragmentation?
Well, there is fragmentation. It becomes sad when there is, but sure.
Yeah, because, a request is very short, but when there's an encryption algorithm, encryption data coming back, the response can be very long, and when DNS is delivered over UDP, it's really likely that the response is going to be more than 1280 bytes, and you're going to end up fragmenting.
Yep. And there are all sorts of crazy hacks being discussed in DNSOP, or actually kind of clever hacks, where you send a packet, you assume it's going to get fragmented, you automatically send hey, this might be truncated, try again. There are hacks being developed.
Yeah.
And they're sketchy.
Yeah.
They're cute.
So anyhow, DNS is essential, and it relies on IP fragmentation. So you're off the hook. But Chris Morrow is on it.
He's the Munich taker, right? So
oh, okay. You're off the hook. Okay. If you believed that IPv6 fragmentation had some serious problems, would you wake up and say, oh my God, I should pay attention? What do you say, Stephen Farrell? Would that be enough to get you to pay attention to the presentation?
I'm already paying attention, but Warren knows the answer.
I don't think anybody would be shocked if you said that IPv6 fragmentation has issues.
Okay.
At least I hope people wouldn't be shocked if you say IPv6 fragmentation has issues.
Let's talk a little bit about what those issues are. I see I've woken you up. Let's talk about how IPv6 fragmentation works, or for that matter, IP fragmentation, period. A packet comes in. It is larger than the MTU going out. So you chop it up into segments. Every segment has an IP header. Let's talk about IPv6 fragmentation. It's the easiest. It has an IPv6 header, followed by a fragment extension header, followed by stuff. And the stuff is the original packet that you had to salami up. The first fragment has the TCP header in it. Does the second, well, if it's a TCP packet, if it's a UDP packet, it has the UDP header. It's the transport layer header. The second fragment, does it repeat the transport layer header? How many say yes? Good, good student. No, it does not. So let's think about this for a minute. How would a stateful firewall behave if it saw, let's say we have a stateful firewall, and its policy is to admit all packets directed towards TCP port 80. Can it process the first packet, the first fragment correctly? Yes, it can, because it can see the TCP header. How does it do with the second fragment? Did I say stateful or stateless? Sorry, stateless. The stateless guy has two options, both of which are bad. One is to pass the packet, which means he passes more stuff than he should. The other is to drop the packet, which means he might as well have dropped the first fragment too, because it can't be reassembled. Let's talk about load balancers, again, stateless. If they're load balancing based on the transport layer port, did they do a good job? No. Okay, so we've convinced ourselves that IP fragmentation breaks some middle boxes, some stateless middle boxes. There are also some interesting security vulnerabilities associated with reassembling things. Overlapping fragment attacks, attacks in which you send a bunch of fragments which you know damn well can't be reassembled because there's one fragment missing in each packet. So it's a resource exhaustion attack. Other problems with fragmentation. So what we're doing in this draft is pointing out that fragmentation breaks some things, pointing out that there are some things that operators and protocol designers should be doing. First, we should not be designing new protocols that rely on fragmentation. They will be as fragile as fragmentation is. Second, for those protocols that do, particularly DNS, we should go back and look at a way to break that dependency, because the application is going to be only as stable as fragmentation is, and that's not very stable. And that's all I have to say. We can all go out and go for a walk in the sunshine now. But questions? Arguments? It's over.
Any blue cheese? I only get one. Where is the other blue sheet, please? If somebody has not signed, so next time we will avoid to get a room with 10 seats. So please put your name here. Thank you, Tobias, for Jabber. Thank you, Chris, for taking the notes. Meeting is adjourned.
See you next time.
No, you're a nice speaker, honestly. I know your work.
I had to wait things up.
Yeah, it was excellent.
Even I didn't care anymore.
Yeah, true. It was excellent. Honestly.
By Friday, I don't care about the presentation, neither does anybody else. You have to do something to make it.
By the way, can you show me how to put the the draft from Fernando?
Oh,
Yeah.
how to upload it?
Yeah. No, upload it, it's okay. Or to pass it next step.
To pass it up?
To become an RFC, right? It
Oh,
went to the-
okay, okay. What you do is go into the tracker.
Yeah. You can include that so it takes time.
Let me get my glasses. Because I can see none of that.